Okay, I basically, you know, made, built this little square wave oscillator for shits and giggles. I was actually going to do it. Uh, I was actually going to build this a few weeks ago, but I was like, who cares? I mean, you have plenty of square wave generators. You got 555 timers and stuff like that. I mean, why would you want to use an op amp, you know, um, for it? But yeah, the other day I started looking at this again, and I noticed that that's why I decided to experiment with it in Falstad, because I was like, I wonder if the duty cycle would remain constant. Because like you vary a 555, you got to change more than one resistor if you want to keep a 50% duty cycle on a waveform, right? And change the frequency. So if you just vary one resistor, you'll change the frequency, but you're also changing the duty cycle. And there are a lot of oscillators that are like that. Even a multi-vibrator, you're going to have two sets of capacitor, like with two transistor multi-vibrator. You'll have two sets of capacitors and two sets of resistors, each of which control half the duty cycle. So you'll get the same kind of effect. Um, but of course, as an Arduino, you could easily generate waveforms, kind of like that. But then again, this generates AC waveforms, AC square wave waveforms. But you only need to vary. You can vary any one of these resistors you like to change the frequency. In fact, this resistor right here is governed by this here. So let's increase that. That makes it slower. That makes a much higher frequency. So so I mean, yeah, it works, and it's just like that Weinberg's oscillator is producing a dual output square wave. Now, of course, you could make this with a 741 and only on a single supply, and then you would get just like a positive square wave instead of an AC square wave is one option. Because I mean, this should work either way, but you would certainly have to have this stuff referenced though to a very low impedance center ground, so that's a little difficult. You can't really easily do that with just a resistor voltage divider. I mean, because you're trying to charge and discharge a capacitor here. So it's not just for reference, in other words. So it would be a little trickier to do with a single supply, but it could be done, but you'd have to provide a low impedance path, and that means it would get complicated, so it's better, in many ways, just using a dual supply. But at any rate, the circuit I built, is pretty much, right there. So, um, that's part of, it's on the same circuit board as this other, that noise effect, sound effects generator, which is still functioning, as it should be anyway. Actually, let me check that real quick. Uh, okay, yeah, that's still working. Um, Get that off the screen. But yeah, so like I said, you can see the square wave it's generating right now. Um, let me. Okay, yeah, I got it in roll mode, so. But anyway, so you can see it's generating a pretty low frequency right now because I got it set to like 100K. But I'm just I'm changing that that bypass resistor here. That same resistor I varied. Again, you can change either these two resistors too. And I'm not using these values. Like I got an 8.2K resistor for one of these, and then a 2.2K for the other. Just whatever I had lying around on the desk. But you can see what the frequency is. If you change one of those resistors, one of these two, basically it's subject to a, you know, a logarithmic term here, so, that in theory would make it kind of a logarithmic variation in frequency, whereas it's going to be more linear if you just change R, which is this resistor. So, basically it works out, just like they're talking about in these formulas. So, to kind of get to the bottom of it. But at any rate, if I go, change our resistance, down to more smaller levels, we're getting, about 900 hertz or something like that right now, 95 hertz, and got it set to 4K and to like 120 hertz. Go to 1K, okay, we're at 400 hertz. But you can see we're still looking at a 50-50 duty cycle no matter what. So, and let's go to like 400 ohms. Okay, yeah, it's starting to look a little squirrely now at 980 hertz. So, I mean, it's not looking like much of a square wave at the moment. So, yeah, that's a little curious. I'd have to investigate that. I mean, again, I am getting down, I got like 400 ohms, so at some point it's going to be overpowering the op amp, so that's probably the territory we're in. You probably would want to use larger resistor values, as always on Falstat circuits than what you see. Because, yeah, I would imagine it's going to, charging and discharging a capacitor like that. It's doing that through the output of the op amp. So I would imagine as I start to make that resistance pretty small, it's probably going to start, doing funny things to the waveform, because that's getting down to, a couple hundred ohms. And again, given the voltage, 9 volts or so, say 10 volts, it's like 10 milliamps. I wouldn't expect it to be that big of a problem, but but it certainly is starting to become one, at 300 ohms. So, at 600 ohms, it's starting to resemble more of a square wave. But again, I think that's what's sort of going on, Anyway, it, 1 kilo ohm, that's about where we're at. So anyway, I mean, it's still pretty cool, but yeah, I would choose, if you want higher frequencies, I would use, I put a, pretty honking big 470, oh, you son of a bitch. I put a big, 470 microfarad cap in this thing. But yeah, I mean, it's like I said, yeah, the waveforms, oh shit, I turned it all off. The waveforms start to get, holy shit, pretty crazy, anyway. But, so it's a neat little, it's a neat little oscillator, like I said, giving you, 50% duty cycle no matter what you're, and being able to just change one resistor, to get a lot of different effects. It's pretty cool. So, anyway, cheers.